Hi everybody, I'm Runal. I'm from Amsterdam, and thanks for attending my talk. In this talk, I'm going to give a brief overview of the entire tech ecosystem from immersive ecosystem perspective, consisting of AR, augmented reality, virtual reality, and also going to dive a bit into Holofill, which is my own product, which fits into this ecosystem. Okay. So before that, I want to give a brief idea of who I am. So you are familiar with my background in a brief manner. I did my bachelor's from computer science in computer science from Pune, from Vishwakarma Institute of Technology in 2004. I worked in India in Pune for a few months, for a few years, and then I moved to Silicon Valley, where I was doing my masters. I'm originally from not from Pune. I'm originally from a very small place called Devgarh, which is in Konkan, in Sindhudurga district in Maharashtra. Uh, After I was in my master's program in Silicon Valley, my focus was primarily into storage systems because that university was primarily very good for research in storage system, operating system, and that was the reason I was there. Because at that time I was focused fully on infrastructure like operating system, storage system, etc. Uh, then I came back to India after that immediately, because I was heavily influenced by socio-economic entrepreneurship, like social entrepreneurs. I worked with my friend to set up a company. He's a very successful entrepreneur in India now for a very brief time. I worked in NGOs. I did a lot of activities in socio-economic related stuff, including publishing papers to create jobs in India's internet cafes. And then I left after 2 years. I left for after 2 years of India stay, in which I got a lot of practical experience. I went to do a PhD in CWI Amsterdam, which is a very top group in database architecture. It ranks very high, like in top five in the Europe in database architecture, top 10 in the world. We compete with Stanford, Berkeley, MIT, etc. Some of and the primary reason of going to this group was because they were one of the top groups and they had a successful history of starting commercialization of products, research out of their companies, and we have some really successful companies that have come out of this group. So that was briefly my academic background. I worked in industry for some time, some years in India during after my bachelor's. Then I was also briefly in internship during masters, and also I was in Silicon Valley for a very high-profile research project in which Oracle was trying to build their own uh, hardware and software for accelerated databases in Silicon Valley during 2014-15 period, part of my internship. I filed patents, published research papers in top conferences during this period, including filing patents as a part of my product. I'm also a mentor. Apart from these activities, I'm also involved in a lot of other activities. One prominent being I'm a mentor in a fashion tech accelerator in Milan for a few years, in which my primary responsibilities are evaluating startups, a few hundred that apply to be selected in the top 10. There is a lot of technology happening in fashion, in 3D, in try-ons, in AI, etc. So I'm one of the core guys in that. I also established a community for makers where we had a collaboration with a private company to use their makers lab, where we had access to 3D printers, laser cutters. So I kind of mentored a bunch of like some 30 20 30 projects as a part of this, immediately as a part of after my PhD and during my PhD also. I did some crowdfunding experiments to publish some of my photo projects. I'm a semi-professional photographer. I have traveled around the world, so I published some books on that. During COVID, I was stuck in India when I created some photo project to promote tourism in Konkan part of the region, and they are live and they are getting quite good amount of response online. Apart from that, I advise startups. I'm part of different amazing communities, and I'm very passionate about socio-economic awareness and upliftment in India and other parts of the world. So I'm also involved in different projects of that type. So that's briefly my background to give an understanding of what kind of a person I am, apart from and my personal activities. So I'm in general an adventurous person. I like to work in the crossroads of technology, art, sciences, and more on the intersection of creative and technology side. So Holofill, which is my current product, is basically a product that has came out of this passion, even though it has no direct correlation with my active PhD research that I did, because my PhD was in databases, while the current product I'm working in more on hardware design, 3D and immersive technology, completely different. And this is something I started purely because I got interested into this field towards the end of my PhD, and I wanted to build my own company as a part of, that was always the vision. Okay, so that was more or less about me. About the overview of the talk, I'm going to talk about overview of the 3D design softwares which form the content pipeline to create content for immersive technology software ecosystem. Then I'm going to give you overview of hardware displays from the state of the art to the basics, from the basics to the state of the art, including AR, VR, and other aspects. And then I'm going to briefly cover for the last 10 minutes Holofill, which is my product, and the ecosystem of products we have created in this. Okay, so starting from the ecosystem for the kids, the idea is basically to make kids interested into creative landscape of 3D design. What exists at the moment are some things like Scratch programming language, which is a MIT programming language, which allows people to do simple visual programming. People are also doing 3D printing. There are workshops for kids to design these things, and there are a lot of people making a lot of money on that. Another advanced stage is robotics programming, which requires a bit of programming knowledge, which comes into picture around 10 12 years of age old kids, where they are taught how to do simple activities. What we are trying to do, so this is what exists in the current landscape: programming languages, robotics workshop, 3D printing workshops, etc. So these are the three primary workshops that are done focused on kids to promote technology and creativity. What we are trying to do is also how do we inculcate holofill as a part of this ecosystem, where we are saying, instead of using instead of just using being a consumer of immersive technology, be a creator, and start with basics of using existing tools that are available for designing 3D, and use holofill display as a platform where the end goal is to visualize your assets in 3D design, 3D games, or any related aspects into holofill, so that there is a constrained environment with a design mindsets where kids are trained how to do that rather than some random things. So, and then they can be moved to more complex programming environments which require more complex understanding, but start with basic, give them an incentive, and that's why how we are trying to use holofill cardboard, which is one of our products focused on consumer approach, to have inculcated in this ecosystem. Now, what are the basic parts of this ecosystem? The basic part of a 3D ecosystem software is 3D models. This is basically the asset that you create from scratch, or there are existing assets that are available that you download, and then they use them to animate, create games, etc. So there are softwares are available that allow you to create these. Then the animation part is where you are moving the asset that is created by to give it some life, to give it some motion. It could be a simple asset like a cube that is moved from point A to point B, and that's a simple animation, or something turning. A complex animation could be if you are designing a human body and then it is moving, it is having some action, etc., or any living organism, etc. So there are different types of animation. Or if you are doing some animation of a clothing item where the cloth is flowing or the water is moving, fire is burning, so all these are different types of animation. They form in different categories like simulation, character animation, solid body animation, etc., etc., and there are different softwares available to do that. And then the final one, and these two first are more on the artistic side, the final one is more on the apps and game side. The third one is more on the apps, and which involves programming. So if you are inculcating programming, and if you are doing something where the animations models react to certain actions which is written using a code called script, then you are creating a game or creating an app, and then that can be interactive where you are using 3D skills and programming skills to do something at the programming level. So that these are the primary three areas in which these things operate, and now I'm going to move to the ecosystem of software, starting from Tinkercad.
Okay, so Tinkercad is a very popular program that is being used for helping kids learn about how to do basics of 3D modeling. It basically has drag and drop options for blocks of cubes, spheres, and more complex shapes. and you can do then export of models with 3D modeling, etc. So there are dedicated companies building workshops, etc. on Tinkercad. So it's quite popular. Uh, then you have Pixcap, which is a animation program which allows import of models, and then you can do animations simple to complex on this. It's also a free a software basically. Blender is a very popular software which is a more advanced software once you have basics of understanding of what is 3D basic 3D animation, because it allows you a one-stop solution for doing everything as a holistic program basically. So you can basically do complex modeling, complex animations, do different types of simulations like fire, different VF effect, wind, like blast and all that kind of stuff. So, and it actually was created in the Netherlands some 20-30 years ago, and it's being run by a foundation now. So Blender is a very popular program that has evolved quite a lot, and you can do lot of stuff in it. So once you get hang of basic stuff, it is always advisable to learn Blender, and then eventually there are a lot of tutorials available to learn more about that. So these were primarily about 3D modeling animations. The very popular program further is Unity and Unreal game engines. So these are two separate softwares. They are primarily called game engines because they allow you to build games. So whatever games that you see in the real world, either on your PC, on your lap, on your Xbox, PlayStation, or on your mobile phone, iOS, like Candy Crush and all of them, most of them are primarily built in these softwares. They have their own advantages, disadvantages, and at the primary, what they allow you is they allow you to import of models because they are a programming framework, and then you can write programs in using C sharp scripts. So in Unity, it primarily uses C sharp programming language, while Unreal uses C++. And then there are a lot of scripts. So if you press a key button, something is happening in the model. So it is moving or it is jumping. So you program actions and reactions and a lot of complex stuff, and then build a full game. So that's basically how a game is built. So this is more on the programming side, and you can do a lot of crazy complex stuff with this. But at the fundamental, this is what they are. So, so those are primarily the software landscape that is starting from a very simple program like Tinkercad to more complex like Blender, and then to programming software framework which are allowing you to do game programming. Now I'm going to give a holistic overview of these softwares in terms of the entire landscape. So you can categorize all the 3D softwares that exist in the ecosystem at the moment into couple of different groups. So whatever softwares I talked so far from 3D angle were primarily artistic softwares. So like Blender, then there are Blender is a free software, but then there is a very famous software called 3D Studio Max. It exists for 20-30 years now, or Maya, or Cinema 4D. Uh, Keyshot is another one which allows you to only do rendering. They are not modeling softwares. So all of these are basically artistic design software because they allow you to create models that are primarily used in games or artistic designs. While the other ones are parametric softwares, which are CAD modeling. So, for example, industrial design. So, if you are using a physical product like iPhone or any physical hardware in your hand or in your work, its design primarily happens in a CAD software, computer aided design. That's the full form of CAD. And then there are some amazing software that exists in the world. SolidWorks is very famous. FreeCAD is primarily a open source software like Blender, so it is completely free. They just recently released their latest version in a stable manner. Then there is Autodesk Fusion 360. So the primary difference between these two, what is a parametric software? Parametric software basically allows you to, it builds a model using mathematical formulas. While in the artistic design software, imagine you are building some kind of a human body as a shape. So human body has a contours. It has different shapes. It has different sizes. So so it has a surface. Now, in a 3D artistic design software like Blender, these surfaces are called mesh, and they are typically created using tons of polygons. It's like a triangle, hexagon, etc. Depending, that's their fundamental unit. So you combine a lot of them together and then you make a surface. While in a parametric software, it is all done using mathematical formula. So there is no triangle or polygon there. So everything is parameter based. So it's a mathematical formula because these are solid bodies, products that you are creating. So these are the two fundamental differences between these two. Then, so these are the primarily the modeling and animation software. Now, if you go to specific domain like say fashion, jewelry, you see the products in there. You have a jewelry, you have a ring, you have a design that gets created for that. So then you have specific softwares in 3D modeling designed for that category of product. So they will allow you to do a lot of amazing stuff in a very fast manner than a generic software like a Blender or SolidWorks, so that you are making jewelry in a very, very fast manner. So they will have a lot of templates of jewelry designs already available. And or if you're looking at fashion, there are some softwares like Marvelous Designer, Z Emotion, or Sklo. They will allow you to build 3D clothes, and then they will allow you to put these clothes on some 3D models in a pure virtual manner, and then you can have a pure simulation of this clothing, etc. So this way, there are industry specific 3D modeling softwares that are designed so that that industry uses those softwares to build products like jewelry, fashion, architecture, etc. And then there are different types of this, and I'm just quoting here the fashion design one. And then there is a Unreal and game engine that I told already what it is and what kind of things do they do. So the entire 3D software landscape can be categorized in these kind of a couple of different category, primarily as an artistic design software and industrial design software. In industrial design software, dimensions and uh, kind of a tolerance is very critical, because when you're designing a iPhone, you don't want to have even a slight millimeter tolerance, because the iPhone will not get built correctly. While if you're building an artistic model like a human or a other thing, you can have certain amount of tolerance. So that is the reason they have different way of fundamental architecture in terms of how they work at its base. Now, I will briefly, because there are a lot of students, I will briefly talk about some careers that are in this field. So there are a couple of different types of careers. They primarily span artistic and programming oriented careers. So one common one is modeling and animation. This is what you see typically in studios, like animation studios or VFX studios when they are building special effects, etc. India has a lot of animation studios. A lot of Hollywood work gets done in India, and there are people employed. They typically have creative art degree or animation courses, etc. And in this also, there are a lot of different specialization. So somebody could be a generic artist. So he will be when you say generalist, it means he's basically doing everything. He's building a model. He's creating texture like skin on that model. He's creating animation. If it's a human model, he's doing rigging. By rigging, you mean you are putting bones in that model so that that model can walk, because a organic model has to move, and then that motion has to look realistic. So that's called rigging. Or there are VFX. So these are different fields. Or there is lighting, like how the light plays a role in special effects. So each of these fields could be individually specialized, and there are people dedicatedly building their careers only focused on that. But then there are also people who are generic, who do everything. So this is more like an artistic path. Then you have game programming. If you like a bit of art and game and programming, then you can do game programming and build games, and that's a very prominent career. The latest one in the last 10 years is AR, VR, augmented reality, virtual reality, because now we have these new class of devices which are head-mounted displays that allow combining augmentation and physical world, virtual world and physical world. And they are also basically created in Unity and Unreal game engines, and then they're exported, because these game engine softwares allow to build the source code once and then create multiple platform based output. So you can build a game and then you can launch it on Android. You can use the same source code to build a game for launching on iOS or launching it on Oculus Quest. So this is called cross compilation. So you are building for different platforms, and then these programming frameworks allow you to create one source code and build for different platforms depending on the need of the user. And then the last one is Web 3D, because we have websites everywhere. Those website also these days have a lot of 3D, like you can move a picture rather than have a single photo. You can grab the mouse and turn it around so you can interact with it. So this involves some aspects of WebGL, web graphics language, or 3JS. So these are some graphics libraries for 3D. and that involves some aspects of web programming, 3D programming, etc., etc. So typically, these are some of the career spanning the software angle. So far I covered in general the software pipeline about the tech ecosystem of immersive tech, and now I'm going to move to the hardware angle. Because in the software angle, we looked at different softwares from the basic Tinkercad to the Blender to game programming, different types of classification of different softwares in 3D. And now we will see for what hardware this platform in a specific way in immersive technology, because we are not concerned at this moment with iPhone and other platforms because those already exist. We are looking at the immersive technology, the focus in this talk. So, uh, in the immersive technology, we hardware. Uh, One is the head-mounted hardware in which it's a wearable hardware. So you put something on your head and like a display, like a VR display, AR display, or you have something which is tabletop, like a TV screen. So you place it on a table and then you see it from a distance, like a regular screen, but it has some 3D angles to that. There is also third angle, which is a bit of smartphone-based AR, but that is like a hybrid of that. So what you have here in the first showing is virtual reality. I'm showing you two examples of Apple Vision Pro on the top and Oculus Quest Pro. And they are called virtual reality headsets because they are basically showing you a completely virtual environment which doesn't exist in the real world. And you can completely recreate them and create a full immersive experience, unlike your physical world around you. The second type of experience, the second type of devices are mixed reality devices. What you see here are two old ones. The first one is on the top is Microsoft HoloLens 2, and then on the bottom is the Magic Leap 2. Now, both of these companies exist for at least around, these products exist for around at least 7, 8 years. Magic Leap even raised almost a few $1 billion based in Florida. And then both of them have stopped the production of these two pioneering devices, uh, while others have taken further next in that. And in the mixed reality, how it differs from virtual reality. In the mixed reality goggles, you actually physically see the things around you, like the way you see when you are wearing your spectacles. When you wear your spectacles, wear your glasses, you actually see real world around you. So when you put these two glasses, two headsets, you actually see real world around you, and then the virtual content or objects or 3D or any objects are placed in this real world. So that's why it's called mixed reality. And in the virtual reality, everything is virtual primarily. So you are being shown everything purely created in some 3D programming software, and then the you and virtual objects are placed in that. While the third category in some basic format is the which is quite popular for a few years now. And then you see a use case here where you are seeing a uh, spectacle being try on a real face, and then it basically will show you different shades and you can check which suits your face nicely. And then there are a lot of variations of these. You can have jewelry try on, you can have cloth try on. So this is a very simple way to do augmented reality, and it's quite popular for both Android as well as iOS. Now we are going to go a bit deeper into these two types of displays, which I told, which is virtual reality display and the mixed reality display. Uh, the classic virtual reality displays that most people know are the cheaper ones in terms of their affordability. Probably, for example, the Quest display, which is from Meta, which originally was Oculus Quest, which Facebook bought around in 2012 for $1 or $2 billion. And then they built on that. So that one costs around, the latest version is Quest 2 or 3, that costs around 250, $300. Uh, while what I'm showing you here are the advanced version of those virtual reality displays, which are not that popular in the market because they're quite expensive. The Quest Pro itself costs around 1,500 or $2,000 on the right side, while the Apple Vision Pro, which was launched this year, costs around $4,000. Now, both of them are at their basic virtual reality displays, but they allow a very unique feature called video pass through. that makes them behave like a mixed reality display, which was the second type of display in which you see the real world. Now, this is a very important classification. I'm going to go a bit done. And Apple, and then Apple has always promoted this product as a like a mixed reality display, but in the reality, it's a VR headset. And what Apple is doing is a very smart thing called video pass through. Now, how it is done? How do you see the real things around you? You basically have very high definition cameras mounted on these displays that are actually capturing the real world around you, and that real world is being fed to you, and the objects are placed in that. So, how does that look like in a small block diagram? In a video pass-through kind of environment in a VR headset. So this is your real world on the left, as you can see. So the real things around you. And there is a camera, let's say as a block diagram. That camera is going to capture that real world, and then it is going to send it to a processor that is on board on the device. Now this processor is basically going to send it to the display that is inside the device. And then so the processor is going to give two outputs. One is the camera feed, that is the real world that it is seeing, and also the digital content that you want to place virtually. So here in the Apple Vision Pro case, this digital content is basically all the apps and games and everything that you're trying to see. While the real world that you see around you that Apple shows you is the camera feed angle, essentially, right? And then all of this is being fed in the display. And then this display basically is behind a very high configured lens, and then that is what you're seeing essentially. So this is the block diagram of a video pass through headset, which is what is typically being done these days in the VR headset. Now, each of this block diagram in this flow chart is having lot of complicated components, and that is where the innovation comes into picture. For example, the display that Apple is using is 4K per display, because you have two displays for two eyes. One of these display itself costs around $700. I mean, two of them. The lens that Apple is using is also very special lens. It's called pancake optics lens. The cameras that Apple is using are so high definition, they have a very small lag, because they need to capture all these data in massive bulk in very fast time, and then the processor is also that much fast. So you can see all of this together makes the final hardware so complex. And then Apple charges you $4,000 because each of these components are quite expensive. But at its basic, what Apple is showing you is what is camera captured and not the real world the way you see in your bare eyes. And that is the reason, if you are trying the Apple Vision Pro, if you move your head quickly like a jerk, you will see the camera lag, and then inside you will see some shake, etc. Because at the end the camera is capturing all the details and it is projecting that on the lens, and that is what you're seeing. So there will be always some delay and some other artifacts that you will start seeing around the objects that you are virtually placing. So this is as similar as your augmented reality environment on your smartphone, in which your smartphone is capturing that real world through the camera. It is showing you on the LCD or OLED screen, and then there are some filters, etc., that you're putting on your face. So this is exactly similar, but in a headset kind of a form factor. Now we will go to the MR phase. So this is where it gets more and more complex, which is the real world that you see. As I told you, in a mixed reality headset like HoloLens 2 or Magic Leap 2, you actually see real world like the way you see the world around you when you're wearing glasses or spectacles, etc. And then there is very complex optics that goes behind that puts virtual objects in front of this real world. So there is no camera involved here. There is absolutely no camera here. You actually see real world through these glasses, and then there is complex optics built around it using different mechanism that puts things in the perspective. And that's the reason these displays are not popular and also very expensive. And these companies stopped the production because they were hitting a wall. The latest in this category are in this year launched glasses only, the smart glasses form factor devices. You must have seen the lot of advertisement from Meta Orion in the recent Facebook Meta developer conference, where Mark Zuckerberg was showing their glasses. So that's the on the left, and on the right, Snap also launched their spectacles, which are similar principle that you see the real world. But you can see from here how bulky these two are. And these are around almost 7 8 year old production pipeline latest devices, while these are the ones which are latest also in the prototype. But you can see the compactness of the form factor here, and they are also prototype at the moment. Now this is a very complex in terms of optics, because there is a lot of high-end optics going on here, and we are going to see what that looks like in a bare minimum block diagram here. So what is a mixed reality display basic fundamentally looks like at its very bare minimum basic blocks. So on the extreme right, you can see you have a visible eye that is seeing the way it was also in the VR headset. uh, then in front of the visible eye there is a big box which is called an optical combiner. This is one of the most important part of a mixed reality display, including your Meta glasses or Snap Spectacle, Magic Leap, or anything. And uh, this is called optical combiner. What it does basically is it allows the real world pass light that you see around to come through it, because it has that kind of a transparent material. But it also allows projecting virtual content on it in a very specific way, so that the virtual content appears in a small portion of that glass at in a small specific angle or something like that. And this component is typically they have different types of component. A very common used one is called diffraction waveguide. So that's the name of it. And if you remember the physics and optics, there is something called diffraction of light. So these are some special materials, because light behaves as a wave. They basically operate on the principle of total internal reflection of light. So light is kind of projected on this special material at a very specific angle from the sides, etc. And then this light stays inside this optical chamber that is very thin, and then it bounces off because it's a total internal reflection, and then it is taken out at a specific angle in front of your eye, and that is how you see it. So if you look at on the left side fully, you see the real world. So that is what you're seeing, because the optical combiner is allowing you to see it. And on the bottom side, you see digital content data generated by processor system. So this is basically your content. Imagine a projector. So projector requires input from some PC, from some laptop, etc. So that laptop providing the feed is your content. And then there is a projector, that red thing that you're seeing. But now this projector or a display is at a very, very miniaturized level. So that it fits into that small compact glasses. For example, in the Meta glasses, if you see on the side, there are thick. That is the reason these things are so thick. They have small projectors on the side that are firing very optical lasers in these glasses from an angle, and this light is getting bounced. And then this projector display is basically firing the light on the optical combiner, and then that is how you are combining a uh, projection that is of the digital content in your real life world. And using principles of optics, you see it on your eye at a very basic level of building block diagram, how internal reflection looks like. If you look at the new block I opened up on the right, that's a small projector, and that vertical strip of blue thing that you see block is a diffraction waveguide material, uh, as a use case. And then you're passing RGB lights essentially, and then this RGB light is projected on this diffraction waveguide material optical combiner at a specific angle, such that when the light enters, you if you remember, there are principles of reflection and refraction. So every light, when it hits a different medium of different density, it gets bent, and then some amount of light is reflected at the same angle, and some amount of light is refracted. So using this principle of optics, here you use the principle of total internal reflection, and then the light is trapped because it is projected at a specific angle, and then it keeps on bouncing, and it travels from one side to another side, and then there is specific amount of opening that is created on this on in front of your eye, and it exits from there essentially. So you can see it enters from a path from a different side, and it exits from another path in front of your eye. And this entire thing that you see is a transparent see-through optics, because of which you can also see the real world outside the that exists around us essentially, right? So this is basically fundamentally what a mixed reality display looks like. And this is very complex. These etchings that you see, these diffraction waveguides have materials. They sometimes are created at nanotechnological level using special fabrication material. And then there are very different techniques. There are different kinds of materials that are being used for that. So production of these materials is a material science research choice and the option. So it's a lot of physics based principles at the work here, and there is a lot of breakthroughs happening here. People are finding different materials. For example, Meta has said they have introduced a new material, while the uh, while the Magic Loop we were using different materials. So this is a lot about material science at the play, and a lot of people are trying to do a lot of different stuff, and there are dedicated companies doing different amazing stuff in this. So this is basically at the fundamental of a mixed reality display. If you understand in general at the basic of it. Now, people are going even further than that. Now, you saw so far something that you put on the headset. The latest people have also tried is smart contact lenses, in which all of this optics, that whatever you see, has been miniaturized to the level of a contact lens. And then there is a company, Expansio. They are actually founded from Russians, but they moved to Dubai. So now it's a Dubai-based company. Last year they raised around $40 million. Uh, I got to know about them because they approached me last year to buy one of my product for showcasing their display, and I met them again in Vienna last month. And this is a small demo video showcasing what their technology looks like. Let me see if you can play it. Can you see it? What you see here is a lens. Inside you see some green things. Those are actually uh, text appearing, and these are the lenses. You can see a small blinking LED. So the idea here is you put this lens on top and you start seeing text in front of your eye, directly in front of your uh, eye, directly. So it's even at the smart contact lens level. So, okay, so that is basically a smart contact lens. So that covers a range of hardware from virtual reality displays to mixed reality displays to even more complex one, which are called smart contact lenses, which are being developed. They expect at least 4 or 5 years of things to go in this field. The other angle is something called tabletop displays, because I told you in the beginning, we have two types. One is a head mounted display, and another is tabletop display. So this is a very famous display. It's a volumetric display. By volumetric display, what it means is you can move in 360-degree around it and you will see different side of it. It's a very experimental display. I think it's from a company called Voxan Photonics, and I think they're an Australian company. The other one is recently a startup from US got quite famous called Looking Glass Factory. They call themselves light field displays, but they're actually lenticular displays. Now, what this display does is if you move in front of it, you will see slightly different sides of 3D model. So you see different angles of 3D model. This is actually a very old technique. It actually originated in France, in Paris, almost 100 years back. And you can also know that because you might have seen these museum cards in museums in which if you move your head, you see different angle of some content, and if you move another head another angle, you see something different. So there are basically a lot of small lenses. They block views on the back, and then as you move your head, you see another angle. So it's a very old technique, but these people have done some refinement to that. The other ones are projection displays, and holofill is some kind of a projection based display that is relatively simple in technique in terms of how it is done, but it also is quite effective in creating a lot of attention in a more cost effective way. And then there are also a lot of competitors that we have, but what we have done is we have refined a lot of optics design, casing materials, etc., to create some really good experiences in this entire aspect. So I'm going to switch. Okay, this is some quick demo of some of me wearing some of these glasses. Actually, on the left, you see me wearing Snap Spectacles, which are the mixed reality headset. They use hand tracking in the augmented reality expo in Vienna last month. And on the right side, you see me trying Apple Vision Pro in Viva Tech Paris. On the extreme right, you see Meta Ray-Ban glasses. So Meta Ray-Ban glasses are not like your augmented reality glasses. They don't have display. So those glass that you see are like your regular glass. They just have two cameras on the side which record video, and then there is a speaker. So they are more like a recording device than a augmented reality device. And at the bottom, you see Holofil's demo booth where we got some really good uh, response at the Augmented World Expo exhibition in Vienna last month. So I'm going to give a brief overview of what is Holofil now in terms of my product, in terms of immersive technology. Holofill at its very basic is a projection display that uses a quite old projection technology that already exists, but we have refined that, we have improved that quite drastically. We have IP on the design, we have IP on a lot of very fine-tuned material, optics, etc. that has gone into. And then what we are trying to create is an optical ecosystem of products in this space. So at its fundamental, the problem Holofill solves is how do you capture attention and boost engagement in a physical world. And it's a social display. That means you place it on a table and you see it in a group. So imagine in a retail kind of a scenario, for example, you see that use case of a bird inside next to the ring with the example perfect gift. So that's an example of a retail promotion in which you can open the display, you can place a physical object inside, and you can have animated projections around it. Now, these are animations created into the animation softwares and other stuff. And then this basically creates an amazing experience for whoever is seeing it from a distance, who thinks, oh, as if the bird is actually there inside, and then it's trying to move around that ring. And that creates a immediate attention grabbing kind of a case. And that then leads to further engagement, branding, marketing, sales, etc. So the main problem we solve is how do you capture attention and boost engagement. Now, because it's a display, it can be used in a lot of different applications. It could be for retail marketing. You can also do interactivity with it, in which you program, you create games, you can create content in which you are interacting with a controller. So if you press a button, something is happening inside, you are playing, you are doing training with it, etc. So it's a platform. If you know how to build content, if you know how to do creative stuff, you can buy the hardware and you can do a lot of amazing stuff with it. And we have two types of products in the hardware. We have a consumer display and we have a uh, business display. So it originally started with business display, which is the bigger version, Holofill. It starts around 699 euros, which is primarily targeted for retail marketing, bigger social settings, for events, etc., to basically capture attention and boost engagement. While the and then the bigger display has gone through a lot of iteration in terms of its improvement. So it has gone through a lot of incremental revision to reach the final maturity it has reached so far. While the smaller one is a holofill cardboard, which is a display that is designed so that we can promote 3D design ecosystem for kids to get them interested into understanding about how to build 3D designs, how to build 3D programming, how to visualize their assets. Because what we feel is what is missing is, in general, as you can see in the applications in the next holofill things, what is missing is people are doing 3D printing. People are learning how to build 3D models in Tinkercad at the very young age. But they are doing this in a very haphazard, random way without knowing where this is going to get used in the end. So what we are saying is use holofill cardboard as a platform so that your kid is being trained to keep its limitation in mind and know how to design things so that they look good inside holofill cardboard, so that they have a disciplined approach of making some content. And then we are giving them programming knowledge, we are giving them tutorials. There are a lot of amazing things available. We have launched our own games that go with it. And we are saying rather than becoming a consumer, we want you to become a creator. So we want the kids or young students to learn about how to do 3D programming, 3D design, games, etc., and engage with our displays and use them as a platform. So it's like a digital Lego in 3D space. And rather than just doing 3D printing, do 3D visualization, because that's much easier further. And because 3D printing has costs and other aspects involved. So we have a bunch of games that we have created that you can play with in this space. We have, so this, the second one you see is a mixed reality environment. in which those leaves that you see are real leaves, while the butterflies are animated butterflies. So you can create some really amazing experiences. So kids can be made very creative. You can give them these assignments. Oh, you want to do some amazing kind of a mixed reality environment in which you do this as a stage, in which you're putting physical object and having projections around it and how they're interacting. So like a small theater kind of experience. You can also create educational lessons like that heart, and they look super cool. We have created interactive apps and other stuff in which you can load 3D models, interact with them, move them, etc. Or you can also do corporate gifting. It's a very cool package device and it looks super nice to give as a brand gift to someone. These are some of the games that we have created. We have recreated the classic 2D Nokia game into 3D Snake now, so that it looks super cool in the device. But you can also play it on your mobile phone. So at its basic, these displays are using a screen at the top. So the holofill cardboard is having a mobile phone placed on the top, while the holofill business display had a pre-installed tablet that goes as a part of the display. While for the holofill cardboard, the consumer display, you place your own mobile phone. It could be iOS or Android mobile phone, and then these games are installed on these phones, and then they you interact with them using a controller that we provide you. And this way, we have recreated classic games like Snake, Tetris, Pac-Man, and then you can play them, install them on the mobile, and play with the controller in your device, or you can play these games directly using touch interface. So these are reverse compatible games. So this way, kids can build their own games. We have launched some framework apps that allow kids to learn how to build games. Or we have recently launched a upgradation of to our very famous app, which was for 3D model viewing. So this is one of our recent upgrade to our 3D model viewer app, which is having augmented reality capabilities. So in this small example, what you see is a smartphone, and that girl is a 3D model. She's an animated 3D model, so she can dance in a real life, while that guy there is a real environment person jogging around in the Netherlands. And then you have different functions here. You can export the animation, so you can record it, you can share for fun with your friends, you can export an image, you can upload a model, you can move it around, turn it around, you can export this model if it has an animation, and then you can play that animation in holofill cardboard or holofill displays. So what we are trying to build with these apps and other thing is a closed ecosystem. So we are giving you hardware, we are also giving you software, and we are allowing you to build content yourself, or you can build your own content. So it's a ecosystem using software, hardware together. That's what we are doing at the holofill. We also recently launched a 3D model viewer marketplace, because it is important that people have good models available for free. So it's an open marketplace. We are getting some good traction for this, where people can upload their models, they can download models. All of these models are curated and they are animated. So you can install them on our app. You can play with fun animations. You can export this animation as MP4 videos through our app to play them in our device. So this marketplace is also an open marketplace. So you can also use these models for any of your personal usage, not for professional usage, because these are free models with a personal license only. In terms of traction, we are in the market for a few years now. We started actually in 2018. We have a few patents. We are fully bootstrapped. We launch our business product first, but we were hit by COVID massively during Corona time, because at that time retail was our focus and retail got closed. So we lost massive sales. So we had a major financial problems for survival for 2 3 years. Then then the Ukraine war started in the Europe. That also had a lot of repercussions because our consumer product was launched in the same year and it had inflation and all other issues. Uh, we have won some research grants from Dutch government for different innovation products. Uh, we have won some awards. We have been to a lot of events around the world. We have won some pitches, etc. And we constantly keep on innovating. Uh, this is a small team. I'm the founder. A lot of this purely is my brainchild. And then I have smart people that work with me. Many of them were my old interns, whom I hired later as part-time contractors. And then they worked on a remote basis with me on individual project level. I have a good supply chain of different distributed suppliers from all around the world. We even launched a Indian entity during COVID time because I was stuck in India. So we also have a Indian company of holofill to cater to the local Indian market with a small inventory to sell in the local Indian market, because importing in India is very expensive. So we are also always looking for partnering with people in India or any other markets. So if you are interested, you can always approach us. In terms of vision, the vision is always to create very strong intellectual property based innovative products in the 3D visual space as a coexistence of hardware and software ecosystem. We already have two display hardware products that are doing pretty well. They could do more better, provided we have a lot of money to scale. But we are fully bootstrapped. And we have a range of amazing software that we have launched, and we will keep on launching more similar stuff. The latest one that we are working is a very cool, innovative research prototype project, which is a wearable display. So we are entering wearable space now. We are trying to solve a very unique consumer problem that has a lot of massive potential, and the early prototype look very promising. And if all goes well, we will actually have a very amazing product launch soon, which will completely build on our experience of building all these products to get this rolling into the market soon. And this is a small demo of holofill in action. I'll see. I can play it. Wait. Okay, I have to. Oops. Can you see the screen still?
Yes, sir.
You can see the screen?
Yes, we can see.
Okay. So this is a use case of a retail promotion using holofill as a retail promotion use case in which you can promote your products. The projection is happening from the top. There is empty space in between, and you can basically open it and place any objects inside. So that's primarily what it is. So that's my talk. So this is in general what holofill is. If there is interest to work with us in any capacity, including investors, partners, distributors, um, at the academic level, we are always open for these opportunities, and we are actively looking for raising money now because we need money to grow and scale. So we are also looking for these kind of opportunities if you have connections in that space. And if there are any other interesting things in which we can work together, I'm always open for that discussion. So that's primarily my talk, and I hope you learned something about, in general, immersive tech ecosystem in this space. Let me